Today we're looking at Leetcode problem 1399 called Count Largest Group. So this is a relatively easy problem, so let's get right into it. The problem description says you are given an integer n. Each number from 1 to n is grouped according to the sum of its digits. Return the number of groups that have the largest size. So now let's look at an example to better understand the problem. Okay, here you can see example 1. We have numbers 1 through 13. And we need to find the sum for each of these sets of numbers with the digits. So from 1 to 9, these will all just be the number since there's only one digit. And then for 10, we'll have 1 plus 0, which is 1. 11 is 1 plus 1, which is 2, and so on. So we have 1, 2, 3. 1, 3 will be 4. So here you can see we have all the numbers and the sum of their digits. So now if we look back at the problem, it's asking us to return the number of groups that have the largest size. So in this scenario, we want to find the numbers that appear the most and then group those accordingly. So here you can see 1 appears twice since it appears one time up here and then another time at the bottom. And this will also happen for 2, 3, and 4 since these numbers all appear twice, whereas 5 through 9 only appear once. So in this example, we end up returning 4. So since the question is asking us to find the number of groups that has the largest size, a data structure that really jumps out to me is a hash table. In the case of Python, we can use something called the default dictionary. So for example, we have the key and the value. The key would be the digit sum. So you can see the sum here. And then the value would just be the appearances. So if we take 2, so here the digit sum is 2, and we'll find it once here. So appearances will initially be 1. And then finally passing through to 11, obviously 1 plus 1 is 2. So we have a second appearance. So we can increment this and it will be changed to 2. Now let's move into the code. Okay, so jumping into the coding, I did say that I want to use a default dictionary. So I'm going to import the default dictionary from collections. This is just a library. So I'm going to name the default dictionary D just for simplicity's sake, and we will have the value set to integers because we are counting the number of groups that have the largest size. So this number will always just be a whole number, and we're not going to have to worry about decimals. So remember, we're iterating from 1 to n. So I'm going to say for num in range 1 to n plus 1. And this is because Python's range works by going up into this value. So if we go from 1 to n plus 1, this will iterate from 1 and it will go all the way through n, which is what we want to do. So again, what we're trying to do first is find the sum of the digits in each number. So I'm going to create this variable called digit sum. And we can use the sum function here. So we're taking this number and we want to iterate through it to find each one of its digits so that we can sum them. And in order to do that, we have to turn the number into a string. That way we're allowed to iterate through. We're going to sum the integer of the digit we find, 4-digit in, and then here's where we're turning the number into a string. That way we're allowed to iterate through it. And now that we have the sum of the digits as digit sum, this is the cool part about the default dictionary. Even though we don't actually have a spot yet in the default dictionary for this digit sum, we can just increment it by 1 and we're not going to run into any issues, which is really cool. So now that we've gone through this, again, we want to find the number of appearances which has the max value. So the greatest number of appearances. I'm going to call this greatest appearances. And we can use the max function here and iterate through the values of our default dictionary. Because again, on the left, the keys of the dictionary is just the sum of the digits. And then the values on the right will be the number of appearances. So this will give us the greatest appearance I'll actually say appearance. That makes more sense. And now we want to count through every single one of the appearances, check if it is equal to the greatest appearance, and if it is, we can increment a count variable by 1. So I will set a variable to group appearance, and we can use the sum function again. And I'm going to say 1 for appearance in, and then again, we're looking at the values because these are the appearances. And then only if the appearance is equal to the greatest appearance. So what this is doing is it's iterating through the values again, which are the appearances. And if the one that it's looking at is equal to the greatest appearance, then we know that we have to add 1 to the count right here. Since, again, we're trying to find the groups that have the largest size. So if it has the largest size, we're going to increase this by 1. And then this sum function is just going to sum all of the ones together to give us the number of groups that have the appearances equal to the greatest appearance. So now down at the bottom here, all we have to do is return our variable group appearance. And this should give us our answer. Okay, so I just misspelled this. Whoops, appearance. Okay, now this should work. There we go. So let's submit this now. And here you can see that this solution is very efficient for space complexity. It's not the most optimal solution, but I think any interviewer that would look at this solution would be more than happy with it. So I really hope that this helps. Thanks for watching.